Hello everyone, welcome to today's session. Today in this session we will be talking about this project on Map Your Mind. Initially there was no intention of making this video, but we got a lot of messages from people about this flowchart and pseudocode. People are asking for explanation on how to write the pseudocode and also how to draw the flowchart for the tasks on this project. So we thought maybe making a video might help in one way or the other. So the first thing I'd like to explain in this project is the flowchart. What is the flowchart? A flowchart is a type of diagram that uses some set of symbols to denote or represent a process or workflow. These symbols denote different actions or decisions in the flowchart, with an arrow to denote the direction of flow. So what this is trying to say is that a flowchart is just a diagrammatical method of representing a process or a workflow. Flowchart is not only applicable to the computer development field or software development field. Flowchart is applicable in almost all fields to help design, analyze, or manage a workflow or process. So don't limit the use of flowchart to only web development or something related to computer alone. It's widely used in almost every organization to design, analyze, or manage a process or workflow. The good thing about flowchart is that it can be understood by non-developers and also the developers that don't know the language the process is written. So if you write a code in another programming language and you went ahead to draw the flowchart, if a developer picks up the flowchart and go through it, that developer will be able to understand exactly what your code is about, even if that developer does not understand the language in which your code is written. So it's a very good thing. A flowchart is something that you have to adopt as a developer, something you should know how to use. So as a developer, you should know how to represent a process or workflow using the flowchart. Like I said earlier, that the flowchart is made up of symbols that denote different actions or decisions. So all you have to do is to master these symbols very well. So let me take my time and explain these symbols for you in brief. So let's scroll down here. These are the symbols, some of the symbols actually. So you can see some commonly used ISO 5807 symbols. So this is just like the standard, international standard, right? So these are the symbols here. So the first symbol here is this flow line or arrowhead. This is used to show the direction of flow. It shows what comes in or go out from one symbol or another. This is just the function of this symbol. So the next symbol here is the terminal or the terminator. This symbol shows the beginning and also the end of a process. In every flowchart, you see there has to be a start and also an end to that flowchart. Okay, so this symbol here is used to denote both the start and the end of the flowchart. So the text written within this terminal is usually a verb. It is usually a verb. So start, begin, or end. So these are some of the text that is usually written within this symbol here. Anyone you choose will work so fine. So the next symbol here is the process or the rectangle. This symbol denotes a process, action, or an operation to be taken within the workflow. So the text written within this symbol is usually a verb as well. So just like in the example here, edit video, choose plan, set variable to hello. So all this is trying to say is that this symbol here is just used to show if there is a process, if there is something to process within your workflow. So if there is something to process, this processing is done in this symbol here. This symbol is used to denote that processing. So the next symbol here is this data IO. This IO simply stands for input/output. The symbol is used to denote any data entering into your workflow and at the same time denote any data displayed. So the displayed data is the output of the workflow. In a nutshell, this symbol simply takes in input and produce output in a workflow. That's just the function of this symbol here. It's just an input output symbol. It shows input and also the output in your workflow. So the next symbol here is the decision or the conditional symbol. This symbol is used for decision making. It is used to ask a question in the workflow, and the answer to this question determines the path to be taken from the question. Arrow drawn from the bottom is considered a yes or a true, while arrow drawn from the sides is considered a no or a false. So this is just a decision symbol. All it does is just take decision. Okay, so you just type in your condition in here. If your condition is true, then it goes like this. If your condition is false, it goes either this way or this way. That's just the function of this symbol. It's just for decision making. So the next symbol here is document. This represents a document or report in your workflow. So if there is any document or report attached to your workflow, just use this symbol to denote it in the workflow. So the next symbol here is the subroutine / predefined process. This denotes a process that can be used in the current process. In a nutshell, what this does is to merge two processes together. So when you are trying to add a process as part of another process, you should use this symbol. So this is just what this symbol is all about. It's just like it's merging two processes together. Okay, let's say a process is taking part in another process, so you use this symbol here to merge these two processes. So the next symbol is called the annotation or comment. This provides additional information about a step in your workflow. So there's nothing about this, it just provides an information about a step inside your workflow or flowchart. So you can see they said the line connecting to the step can be solid or dashed. So any of this you use is fine. You can use the solid or the dashed connecting line. It will work all fine. Okay, so the next symbol is this on-page connector. This is used to replace long and confusing lines in your workflow, as they said, right? What this on-page connector does is this. It is used to connect a part of a flowchart with another on the same page. That's just what this on-page connector does. It is connecting a part of a flowchart. Let's say you have a flowchart drawn in this a left side of your page, and also another flowchart on the right part of your page, and you want to connect these two flowcharts together. Instead of you drawing multiple lines, different type of lines into the other flowchart, making it kind of very confusing, so you are just supposed to use this on-page connector to connect these two flowcharts together. That's just what the on-page connector does. While this off-page connector is just the opposite of the on-page connector. It's actually the same thing, but the difference is that this is used to link this to connect these flowcharts on a different page. That is, if the flowcharts you want to connect are on different page, so you are to use this off-page connector. So the last symbol here is the data file or database. This represents a disk drive or database where your data are kept. So if there is the need for a data for a disk drive in your process, then you can use this symbol here to denote disk drive. So here is an example. I'm sure you can just go through the example. I'm not going to spend much time on it. This is actually a simple example. I'll just go to the task straight without wasting much time on this. So let me go back. Here it is. So before I proceed to the tasks, let me explain what this pseudocode is. In a simple form, in a simple English, pseudocode is just a simple version of a programming code in a simple English. It is not a programming language actually. It's just an English-like, not English-like, it's just an English form of writing your problem, okay? So before you start writing your problems in code form, before you start coding your problem, it's ideal for you to make sure you write your pseudocode. Okay, so there's this thing you need to know about this pseudocode. Pseudocode is not kind of exact. Let's say two people are trying to write a pseudocode of the same problem. So their pseudocode might be different, but it might be the same as well. So there is no exact way of writing a pseudocode of a particular problem. Someone has his own of writing the pseudocode, while the other has his own of writing the pseudocode. And if you go through these pseudocodes of these two people, you find out that each and every one of them is correct. So everyone has his own approach of solving the problem. So this is one thing you need to know about the pseudocode. Pseudocode is not a programming language. It's just like an English way of writing your code. That's just what this pseudocode is. And there are a lot of rules. There are some rules about this pseudocode. I think when you go through the materials here, you'll be able to see these rules on how to write these pseudocodes. I'm not going to waste much time on this. I will just proceed to the task at hand. So the next thing I'd like to explain is the algorithm. What is algorithm? Algorithm is just simply a step-by-step process of solving a problem. That's just what an algorithm is. It's not a big deal actually. Algorithm is not just related to the computer world also. When people hear algorithm, they will think like it's something very, very big, that wow, what is this? Algorithm is just a simple step-by-step process of solving a problem. Let's say, for instance, I want to make a cup of tea. So what is the step-by-step process of making a cup of tea? The step-by-step, the first thing, let's say I'll boil the water. The next thing is I'll add a spoon of milk, a spoon of Milo, a spoon of sugar, something. These are just the processes, right? So this is just what an algorithm is. So both the pseudocode and also the flowchart are means of representing workflow. So you can use anyone that suits you, okay? Anyone you like the most, just use it to solve your problem. If you like, use the flowchart. If you like, use the pseudocode to try and represent your process. Anyone you choose is just fine. So let's go to the task at hand. So the first problem here says calculate the sum of squares of given input of numbers. So from this problem here, you'll be able to know that, okay, you have to take in input, right? You have to take in input. So in this case, I'm going to take two inputs, right? Input A and input B. I'm going to take two inputs. So, and what this problem is asking you to do is that for every input you take, you have to square it, right? Square input A, square input B, and at last, at the end, make sure you sum the square of these two inputs. That's just what this task is trying to tell you. So now let's pseudocode this problem here. This is my Google Docs. Let me create a blank file. Alright, so let's start writing the pseudocode. So let's go back to the problem. Okay, calculate the sum of squares of given inputs of numbers. So like I said, we are going to take two inputs, right? So let's say read, let me name it num A, then num B. So these are the two inputs that I want to take. So the next thing is this. We have to square each of these inputs, right? We have to square input A, we have to square input B. So the next thing I will say is set, let's say square 1. It's like I'm declaring a variable square to save the square of this num A. So I will just say set square 1 is equals to num A, right, times, let me use this, num B, right? Sorry, num A times num A. So this is the square of A, right? That's square 1. So the next thing also is take the square of num B. So I will say set square 2 is equals to num B, right, times num B. So I've declared a variable to store the square of this num A, right, which is num A times num A, and also a variable to store this. Okay, so let's go back and see. So calculate the sum of the squares. Yes, so the next thing is to set a variable called sum that will add these two squares together. So I'll just say set sum is equals to square 1, right, plus square 2. So this will store the square of these two numbers here, right? So the next thing is to write sum. So I want to display the result, right, the sum of this square 1 and square 2. So this is just what this task is asking us to do. So like I said, you might have your own different way of writing the pseudocode, and someone else might have their own different way, but it's still work the same. Okay, if someone sees the pseudocode, they will be able to know what your pseudocode is about. So this is just for the pseudocode. So I will just kind of save it. I will just share. Let me just name it task 0. pseudocode, okay, and save. Alright, so change this to anyone with the link. So copy link, done. Then come here, paste it, right, then save. Okay, so now the next thing is to add the URL for the flowchart. So now let's do the flowchart. Create the algorithm in your flowchart, save a screenshot and upload it to Google Drive. So let me open draw.io and see if I can draw the flowchart there. Draw.io. So like I said in the beginning of this video, there has to be a start and an end for a flowchart. So this is it. Let me start the ellipse, right? So let me add some text inside. So start, let me just say start, right? So the next thing is read num A, num B. So this num A, num B are considered what as inputs, right? It's going to take inputs from the user to inputs. So we are going to use this parallelogram here because that is what the shape that denotes input. So I will just say I will add some text inside, just double click to write some text. So the first declaration is what? The first declaration is num A, num B, right? So I will just say read num A, num B, right? Let me increase the size. Yes, so read num A, num B. Yes, so let me check for another variable. Yes, the sum variable. So then what? Then sum. So this is it. So the next thing is what? Num A by times num A. So this is a process, right? The process is what? Multiplying this num A by num A again. So what I'm going to use is this process rectangle here, this process shape, which is the rectangle. So I'm going to say square 1 is equals to num A times num A. Okay, so I will scroll down again and say square 2, sorry, there is no space in here, square 2 is equals to num B times num B, right? So this is a process. So let me use the arrow line, the arrowhead, to define the direction of flow, right? Yes, all right. Yes, so this is it. So just bring it here, denotes the direction of flow. Okay, yes, then pick up another arrow, then put it here, right? So what's the next thing again? The next thing is to display the sum, right? So to display the sum, we are going to use this same symbol here, which is output. It's the same thing as input and also an output. So I will just drag it here and say write sum. So draw your arrow. All right, so that's just it. So the last thing is just the end symbol here, right? That's just the end symbol. So this is it. So just type in end. So draw the arrow, or let me reduce this size. Yes, let's drag this here and this. I'm just trying to make sure everything is displayed within one page. Okay, so drag this as well. All right, so bring it here. Yes, so this is just the flowchart for this problem here. This is actually my own flowchart. This is how I thought the flowchart should look like. You might have your own kind of approach, like I repeatedly say. Okay, so this is just how I thought the flowchart would look. So what I'm going to do now is just I'm going to use my snipping tool. I'm going to use my snipping tool here. Drag it here so that I will save this as a picture. Okay, right? Yes, so I will save it. Right, let me name it task 0 flowchart. Right, so yes, let me save it to my desktop for easy access. So the next thing is just to upload it to your drive. So file upload, desktop, I think task 0 flowchart, yes. Alright, yes, so this is the flowchart that we just drew. So I will just right click, get link. Alright, so just scroll down here, just make anyone with the link. So copy the link, then done. Come back here and paste the link here. Yes, so click on save, then done. So now let's go to the next task. The next task says read in 3 numbers and write them all in sorted order. Okay, so this program is going to take in 3 inputs, right? And it's going to write this input in all in sorted order. What does it mean to for something to be in sorted order? Either in descending or ascending order, right? So that's just what it means, sorted order. So you can choose anyone. So I'm going to choose the ascending order. Okay, so it should be from the smallest to the largest. So let's see how to write a pseudocode for this program. So there is something I forgot to do here. Actually, you are supposed to give your pseudocode a title. What problem are you writing the pseudocode for? Okay, so what's the problem? Let me check. Sum of squares of given input of numbers. So I will just say, I'll just copy this. So it's very important to add the title to your pseudocode. Okay, so this is it. Okay, so I will just save it. So fine, that's all. So now let me create a new file for the next task, document. So what problem are we trying to solve in the second task? Read in 3 numbers and write them all in sorted order. So I just say a pseudocode that takes 3 numbers and writes them in sorted order, right? So it's going to take 3 numbers, right? So the first thing I'm going to say is read num1, num2, then num3, right? So that's the first thing I'm supposed to do, because it's going to take in 3 numbers. So the next thing is to determine the order in which we are going to write these numbers. What they want is that if num1 is greater, if num1 is bigger, it should display num1 first, depending on which order you choose. But I actually said I'm going to choose the descending order. What does it mean to be in descending order is that, so I'm going to start from the smallest, right? It will first check these 3 numbers, which one is the smallest. It will display the smallest number first, followed by the next smallest number, followed by the biggest number among them. So that's just what I'm going to do. So I'm just going to say if, I'm going to use this statement if, because we are going to deal with condition, right? If num1 is less than num2, sorry, if num1 is less than num2, also less than num3, right? So press enter to go to the next line and tab. Make sure you leave a spacing, because if you are supposed to write this if statement in an IDE, you are supposed to leave an indentation in the next line. Same applies to the pseudocode. It's kind of a rule. Okay, so if num1 is less than num2 and is less than num3, what does this mean? It means that num1 is less than all these 2 numbers, right? So I'm going to say write num1 first, right? Then which number? Num2 is the second smallest number, right? Then num3. So I'm done with this. So the next thing I will say, else if else if num1 is less than num3 less than num2, right? So if num1 is less than num3 and less than num2, I will just write num1, which will be the smallest, right? Followed by what? Num3 here. Num3 followed by what? Num2. So num2 is considered the largest number here. Then it's the largest number, then num3, then num1. So the next thing is else if again. So now I will consider num2. So if num2 is less than num1, also less than num3, write num2, num1, num3, right? So in this case, num3 is the largest, then followed by num2, followed by num1, then num2. So else if again. So in this case, else if num2 is less than num3 less than num1. So we should write what? Write num2, right? Num3, then num1. So num1 is the largest here, while num2 is the smallest. So now we are done with num1 and num2. So let's go to num3. So else if num3 is less than num1 less than num2, write num3, num1, then num2. Else if num3 is less than num2 less than num1. So I'll just say write num3, num2, num1. So this is supposed to be the pseudocode. Like I said, you might have your own method of writing the pseudocode, but this is how I thought of approaching the problem. So this is the pseudocode. So if you choose to write this in descending order, this place should be greater than, greater than, greater than, but because I chose to write in ascending order, that's why I'm using less than for comparison. Okay, so this is the flowchart. Sorry, this is the pseudocode. I will just save it, click on share here. Let me name it task 1 pseudocode. Okay, then save. Anyone with the link, then copy link. Done. So come back here, I'll paste it here. So save. So now the next thing is to draw the flowchart for this problem here. So let's try and draw the flowchart. So let me go back to my draw.io. Let me create a new file. So let me name it task 1 flowchart, right? Actually, I'm not going to draw the flowchart for this task because if to say I should draw the flowchart, it's going to take long and the video will be longer. I don't want it to be longer, but here is a picture of the flowchart. I drew this flowchart in Microsoft Word. So this is it. Okay, so this is the picture of the flowchart. So I'm just going to upload it to my drive. You can see this is the picture. Just go through it. I'm sure you will understand. So this is it. This is the flowchart. As you can see, these are the conditions. I drew this flowchart from the pseudocode that we just wrote. Okay, so it's because I don't want the video to be very long. That's why I don't want to draw the flowchart here. So let me upload the flowchart now. Let me just come here, file upload. Yes, so let me refresh. Right, so let me share. Alright, so anyone with the link, copy link, done. So come back and paste it here. So save, then done. So we are done with the second task as well. Yes, so the last project here says calculate a running sum. A user will enter numbers that will be added to the sum, and when a negative number is encountered, stop adding numbers and write out the final result. What this is trying to say is that a user will enter a number, or the user will keep on entering numbers until a negative number is encountered. So the number will be added to the sum. Okay, so you have to create a variable called sum and set it to what? To 0. So that's the initial count. The initial count should start from 0. So the user will enter a number that will be added to this sum. If the number the user entered plus the sum is not a negative number, then it will ask the user to enter another number again. The user will keep on writing numbers. The user will keep on entering numbers until a negative number is encountered. When a negative number is encountered, the program will stop adding numbers and it will display the sum of the previous numbers. Okay, the sum of the previous numbers the user has been adding, okay, to the sum. So that's what we are going to see. Now let's start by typing the pseudocode. So let's create a new file. So let me call it pseudocode for calculating running sum, right? Sorry, running sum. So like they said, the user is going to enter a number. So let's name that number X, right? So the next thing is to set this sum to be equals to 0. That's the initial value of sum. We are going to be adding the value of this X to sum, right? So we have to set the initial value of sum to be equals to 0. So now the next is the condition, right? We will say while X, right, that's the number the user is going to enter, is greater than or equals to 0. Why am I using this condition? Because here they said when a negative number is encountered. So what makes a number negative? A number is negative if it is less than 0, right? So that's why I use this condition, while X is greater than or equals to 0. So it will what? It will set sum to be equals to X plus sum. So that's just what I'm trying to say. As far as X is greater than or equals to 0, it should set sum, the variable sum here, to be equals to the value the user enter from plus the value here. So if the user enters 10 here plus 0, it will be equals to what? 10 plus 0 here, and this will be what? 10. So the user will enter another number again. If the user enters 20, it will check, is 20 greater than or equals to 0? Yes, it is. Then it will execute this program again. This loop will continue unless X is less than 0. So when X is less than 0, this makes X a negative number, right? This makes X a negative number. So this is when the loop will stop. So when the loop stops, we have to what? We have to write sum. So this is just what it is asking from us. If the loop stop, then display the sum. That's just what the program is asking. So this is just how the pseudocode is supposed to look like. It's a very simple thing. It's just that understanding the concept is difficult, but when you get it, it becomes easier. Okay, so this is the pseudocode for this particular task. So let me share it. Let me call it task 2, right? Task 2 pseudocode. So I will save. Right. Oops, did I copy the code? Okay, copy link, then done. So come back here and paste it, then save. So we are done with the pseudocode. Now the next thing is to create the flowchart. So let me go back to my flow.io. Where's the pseudocode? This is the pseudocode, right? So the first thing we are going to do is to start the process. So I'll just say start, right? Let me drop this here for now. So the next thing is what? Read X, right? That's an input. So let's take this. So I will just say read X, right? So the next thing is what? So this is a process, right? We are setting sum to be equals to 0. So I will just come here. I will say sum equals 0, right? So the next thing is what? A condition while x is greater than or equals to 0. So I will drag this diamond shape here. This is it. Let me pull this up a bit. Yeah. So what is the condition? While x is greater than or equals to 0. Okay. So I will say while x is greater than or equals to 0, right? So this is the condition. So if you can remember, when this from the explanation of this flowchart in the beginning of this video, if the condition is true, the arrow goes like this. If the condition is false, it goes either this side or this side, right? So let's go. So set sum is equals to x plus sum. So this means that if this is true, we should come down here and write this process, which is sum is equals to x plus sum, right? That is if it turns out to be true. If it is false, what will happen? So if it is false, it goes this side, right? So now if it is false, it ends this process, right? So if it's false, so I will just end the process. If this is true, it goes into this, right? And this is executed. So it comes back here to this condition here, decision, and check again. Is the condition true? It execute this again. So it will keep running the loop. The loop will keep on going until a negative number is encountered. So when again negative numbers are encountered, this make this decision false, right? So it goes this way. So this ends the flow. Okay, this ends the flow chart. So now let me connect it. Yes, so you can see this is the feedback. When this condition is met, this is executed and it comes back here and check again. If it's met, it comes to this again. So it keeps checking the loop. The loop keeps running until x is less than 0. So this, when x is less than 0, it ends the flow. Okay, it ends the flow. I just tried to show you how mine is. Okay, so let me just zoom out, and I'm just trying to make sure it is in one page. So let me open my snipping tool here. This is new here. Yes, new. So just save it. Yeah. So task 2, flowchart, then save. All right, so let's go back to the project. Sorry, let me go back to my drive and upload it. All right, refresh. Yes, this is it. Save, then done. So this is how you can be able to do this project on this Map Your Mind. Actually, like I said, you might have your own method of writing the pseudocode and also drawing the flowchart. So I just hope this video is informative enough. If you find it interesting, do leave a thumbs up and also subscribe to our channel, and also make sure you click on the notification icon to get notified when we post the next video. So thank you very much till we meet in our next session.